Improving cooling system efficiency, part 5, putting it all together. So let's just take an overview, stop and take an overview of what we've just talked about in the previous sections regarding how these different components of a HVA system work together. Starting with the warm room air that in the building, if we take that into the air handling unit and pass it over a cooling coil, it will reduce the temperature and also reduce the humidity by condensing out moisture from the air to produce liquid condensate. The heat that is given up from the warm air through the coil is picked up in the chilled water loop that flows through the evaporator section of the chiller. So that water, that closed loop, continuously circulates through the evaporator, picking up heat. The heat from the chilled water is transferred into the refrigerant, normally Freon, in the mechanical chiller, and that compressor compresses the refrigerant and transfers the heat of compression into the condenser of the chiller. And that heat then is transferred into the condenser water loop. That water passes through the heat exchanger of the condenser. The water is pumped up to the cooling tower, as we've seen, flows through the cooling tower, and by evaporative cooling and sensible heat removal, the fan pulling the cold air through the water flow evaporates a portion of that water to cool it so it can be recycled back through the condenser where it picks up more. There's another illustration that kind of shows the way in which this heat transfer takes place and the resultant energy that's required to accomplish all of this. Here we see warm air from the building is picked up in the air handling unit that transfers the heat to the warm chilled water, warms up the chilled water. That chilled water then passes its heat to the refrigerant in the chiller. The refrigerant passes into the condenser section of the chiller where it gives up its heat to the condenser water, which flows to the cooling tower, which gives up its heat to the atmosphere. So you can see there are several steps in this heat transfer process, all of which require energy. We've got energy required to drive the compressor motor on the chiller. That's a big one. But we also have energy required to operate the chilled water pumps and also to operate the condenser water pumps and the cooling tower fans. So the whole idea to improve efficiency is to make sure that we do this process as efficiently as possible using the least amount of energy and the least amount of water.